Let me add my word of appreciation. Appreciate all those who have been so warm and welcoming and those who fed me. My wife called me this afternoon. She said, "Are you tired?" She said, "How do you feel?" I said, "I feel fat." She says, "Well, I'm going to go ahead and eat all the ice cream sandwiches at home so they're not here when you get here." So isn't that, and that's what a wife should do, look after her husband like that. What a sacrificial spirit that she has. I really appreciate that. Okay. So the kids have been busy again with questions. I don't think I've ever been at church where I got more questions from the young people, and it's been wonderful. And the questions are really good questions too. So Leo Anderson says, "Why do people think that the earth made itself?" That's a good question. And I think it's because they don't want God to be around. Okay? And because they know if they're made by God, then they're responsible to God, and someday they're going to stand before him and give an account of their lives. And that's a terrifying idea for a lot of people. And so they have to have the earth start itself and come about by nothing, or otherwise they're going to be responsible to the Creator God. Next one is, this is from Hope, it says, how many people were on earth when the flood happened? Now, if you think about the fact that people lived a long time, they lived 10 times longer before the flood than they do now, and so we don't know how long they were able to bear children. Let's say you can have children, say, up until you're 40 years old. Well, that'd be like 400, okay, then. And so did they have really large families? Maybe they're all homeschoolers. I don't know back then before the flood. But so the maximum estimate I've seen is 2 billion, because of the longer lives and how long they could bear children. And so 2 billion is kind of the maximum top of that. It could be anything, anywhere from there, so down. So, of course, people want to know, well, where are all the bones? And but you have to understand, with the flood came, the people were able to get to high ground and build boats and rafts and so forth. And so, they weren't buried like a lot of the animals were during that time. I think that's our best explanation why we don't find more bones from before the flood. Sometimes we do find skeletons that are completely fossilized, human skeletons, and so I would think that those are pre-flood skeletons that we find. It says, why does the sun look yellow if it is actually white? So the sun really is white, and you notice it looks different colors depending on how much of the atmosphere it goes through. So if you see it right on when it's going to set, it looks red a lot of times. So the sun's white, but because it goes through the atmosphere, you see different colors. So we were out in a church in Washington State, and there were some flat earthers there. And so they were trying to convince me the earth was flat. And I had never heard this before. I thought it was preposterous. But anyway, they said, and I said, why are sunsets red? And I didn't know that wasn't in their standard repertoire. So they said, we'll get back to you on that. And they took my email address, and I'm still waiting for an answer. Okay. So the reason sunsets are red is because red light bends more than the other colors, and so it bends around the curvature of the earth. So if the earth was flat, you wouldn't have red sunsets, okay? And so I didn't know that I'd stumped them. I wasn't trying to. I was just trying to figure out what they were talking about. So anyway, so sometimes the sun looks red or orange or whatever. But that's because it's passing through the Earth's atmosphere. That's a good question. Okay, so Gabe said, how many moons can fit into the Earth? So I asked the one who knows all, that is Google. And Google said 50. Okay, so 50 moons would fit inside the Earth. And the next question is, how do people get moon sick? And that's a good question, and we don't know yet. So that goes along with my injunction, like Martin Luther, if you don't understand something, give God the honor of being smarter than you are. So maybe someday we'll figure out how the moon makes people moon sick, but we don't know right now. Okay? And then here's one. Sometimes the sun and moon look much larger than they usually appear. Why is that? You ever notice that? When it's on the horizon, it looks, bigger. So that's an optical illusion. Okay? So in order to destroy the optical illusion, I can't do this, but you younger people can do it. What you want to do is lean over and look through your legs at it. Look upside down at the moon, and the illusion disappears. Okay. Plus, you look really funny when you do that. So I'm not going to do it for you up here on the stage, all right? But I assure you that if you just, look through your legs at the moon, the optical illusion disappears. Okay. So it has something to do with the fact that there's like trees and objects on the horizon, and it makes it look bigger, and our brains interpret it that way. Another thing you could do is you could take a coin and hold it up, when it's on the horizon, and then when it gets higher, do the same coin. You'll see it's the same size, has the same diameter when it's up, even though it doesn't look like that to you. It's actually the same size. Okay? So then, why do some animals look ugly? This is from Luann, and the ugliest animal in 2013 was voted on, and it was the blobfish. People think the blobfish is ugly. I think more interesting is, ugliness is in the eye of the beholder, isn't it? But I think more interesting is what kind of animals look cute to us. And it's usually animals with big eyes and fuzzy, pudgy bodies, okay? Maybe that's because, babies have big eyes compared to the size of their heads and so forth. So I don't know. But everybody says that's cuteness. So you notice when they do cartoon characters, and they always give them bigger eyes than would be normal to make them look cute. Okay, then I got a question on black holes. Explain a black hole. Okay, so black holes, the evolutionary explanation, let me put that, is that a star lives out its lifetime and goes supernova and explodes. We see the big flash of light. And then what's left collapses, and because of all the gravity, it collapses into, a very small area, and it has a very high gravitational pull. In fact, the gravitational pull is so great, it actually will not let light escape from it. So that's why it's called a black hole, because all the light is turned back and back into the black hole itself, so no light can escape from it. Now, the trouble with that explanation is that I think it takes too long to make a black hole for the age of the universe. The evolutionists say the age of the universe is about 13.8 billion years. Okay, that's their estimate. But when we look back with our telescopes, there is actually some really large black holes that are really far away. In fact, one of those is actually 13.8 billion years old. Right, there's the black holes that exist supposedly during a time before stars even formed, after the Big Bang, according to the way they think. So that doesn't work very well. So the fact that there's black holes is evidence for the young Earth, young universe. So one of the problems with black holes that you have to think about is, so you have the black hole and the matter spinning around it, spiraling into it. It's sucking it in with its gravitational pull. It goes faster and faster and faster. And when it gets right to the event horizon, before it goes black, it's going almost the speed of light. Now, when things go the speed of light, time slows down. That's relativity. And so from our standpoint, when we look at it, it's like time has stood still there. So if time has stood still, then it never falls into the black hole, and the black hole can't form. So black holes, by my reckoning, should have actually been part of the original creation. I don't think there's any naturalistic explanation for how black holes could have formed in 13.8 billion years. It's just not enough time, especially those ones that are really far away. Now, black holes can be millions or billions of times more massive than the sun. So we have a black hole in the middle of the Milky Way. We've actually taken a picture of it now. And it is not the hole itself, but the stuff around it, okay? And it's called Sagittarius A star. And it's 4.3 million times more massive than the sun. Okay, so that's big old guy, okay? We can also see black holes hit each other. So sometimes black holes collide with each other, and because they're so massive, they collide and they form a bigger black hole. When they do that, we can actually see the ripples in space-time when that takes place. So they have detectors on the Earth, and they have one in Italy, they have one, I think, Wyoming, one in Louisiana, I think. And so when those black holes hit, it actually cause all of space-time, the wave, the ripple, and those waves actually travel at the speed of light. And so they'll hit one of the detectors first, and they can figure out, based on those 3 detectors, where it came from, okay? So we can kind of locate where those 2 massive big holes actually hit each other. So they're real, but they point to a creator God. I don't think there's any, I looked online again to see what they say, how black holes form, and it said, we're uncertain about how black holes form, okay? So they're uncertain. But I think they go toward creation. Do you have a follow-up by that? A light hole? A white hole, okay? So we've never seen a white hole. It's a theoretical idea, but the idea, Russell Humphreys, in his starlight and time theory, he says God created the whole universe on the edges of a white hole, and say in a relatively small area like 2 light years across, and then it expands at relativistic speeds. And that was an explanation he gave for how we can see light from the stars, almost immediately, how the light traveled here from the stars. So that's a white hole, but we've never seen a white hole. It just exists as a mathematical equation right now. But black holes, we've seen those. So at least we've seen what's around them. Any other follow-up questions on black holes? Oh, yes. Yes, sir. Yeah, you.
Do you know where you would go when you go in a black hole?
Well, what would happen is the gravitational pull would be so great that the pull say you're going feet first into the black hole, the gravitational pull on your feet would be much greater than on your head, and it would just pull you apart. You'd look like an earthworm by the time you got done, okay? You'd be really, really skinny. Maybe I need to do that. Okay. I don't know. Yeah, that'd be helpful. But you wouldn't live to tell the tale, okay, near a black hole. So those are all really good questions. By the way, you see down here I have my stuff to set people's hands on fire. By popular demand, people want to know if I'll set people's hands on fire. So after the service, come down, and anybody who wants to will set your hand on fire, okay, if you'd like to do that. If your parents will let you, okay? And Pastor Wes has agreed to hold onto your arm really hard so you don't do this kind of thing, all right? Because when you do that, it just adds oxygen. It makes it hotter, all right? So don't do that, all right? All right, so that's after the service. We'll have fun with that. Anybody who'd like to do that, we'll make that available to you, okay? All right, so our topic tonight is the age of the earth. Here it is. I called it, it's a young earth after all. So why do I believe the earth is young? How old do you think the earth is? How old does it look? Does what you believe about the age of the earth make a difference? So it's my goal tonight to explain the scientific evidences for a young earth in such a way I hope will be understandable. But first, let me get to the point of why do I believe that the earth is thousands rather than billions of years old. It's because of passages like this in the Bible. Genesis 5, verses 3 through 5, and it says, Adam lived 130 years, and he begat a son in his own likeness, after his image, and called his name Seth. And all the days of Adam after he begot Seth were 800 years, and he begat sons and daughters. And all the days that Adam lived were 930 years, and he died. And there's a lot of these genealogies there. What do you do when you get to them? When you have your devotions, what do you do when you get to a genealogy? Well, if you're like me, you skip over them, right? You can admit it. That's all right. And they get kind of mind-numbing after a while. So we treat them like a expansive desert in between the oases, that we're looking at. But really, the genealogies provide us useful information about how long people lived and the dating of biblical events. And they themselves can be used to refute evolution, and support creation. So why do evolutionists believe the Earth is old? So in this current controversy over creation and evolution, it's a rare event to have something we agree on. And what we agree on is that evolution is impossible if the Earth is young, that is, thousands of years rather than billions of years. Nobel laureate Professor George Wald said in his book, The Origin of Life, and I quote, "Time, in fact, is the hero of the plot. Given so much time, the impossible becomes possible, the possible probable, the probable virtually certain. One is only to wait. Time itself performs miracles." So one of the miracles time is hoped to have performed is us. Okay? You ask the average scientist, how do you know that evolution is true? And he'll say, most likely, well, we're here, aren't we? You know, what other explanation is there? You say, well, how about creation? So, well, that's not scientific. And he's right, it's not scientific. And neither is evolution scientific, okay? They're both world views. They're both, lenses we look through to see, to be able to figure out what's going on. And so creation's not science, evolution's not science, but we can use the tools, of science to actually undermine beliefs in billions of years so that there's not enough time for this miracle of evolution to occur. Well, the reason I say that evolution is not science is because science needs to be falsifiable. So what do I mean by that? You need to be able to carry out an experiment that would possibly show that evolution is false, okay? So what would that experiment be? I had one guy I wrote to online, and he said, well, if you could show me that there were elephants in South America, then I would believe. Really? I said, really? That's all it would take? No, you'd just say, you'd say, well, look at that. There's elephants in South America. Okay. Well, how would that change your mind? The same thing's true for us. No matter what we see, we say, well, God did that, and He used the miracle to do it. I mean, we don't. So neither of them are scientific. Let me give you an idea about that. So here's a picture of some soft tissue and a dinosaur bone. So you'd think that this maybe would be the kind of evidence that people would look to prove that evolution is wrong and that there's not millions and billions of years and so forth. So there was a guy in 2005, and they found a Tyrannosaurus rex skeleton, almost complete fossil, in Montana. And they were in a rush to get it before the poachers got it and sold it on the black market. So they got one of those big Huey helicopters, and they were picking it up, putting it in there. And the door of the helicopter was pretty large, but that femur bone of the dinosaur is really big. They couldn't get it in the door. It was too big. So they did what any normal person would be in a rush. They broke it in half. And when they did that, this guy said it had the smell of death. Now, this is a dinosaur that's supposed to have lived 65 million years ago, and it had the smell of death. This guy had worked in the Bosnian killing field, so he knew what death smelled like. So he took samples of that bone and sent it to Mary Schweitzer, who's a professor of chemistry at NC State. And she dissolved all the hard material off of it, and she looked, and there was all this spongy stuff like you see on the screen, okay? And it looked like blood corpuscles and veins and so forth. And so what did she say? What was her reaction? And here's what she said. She says, it was exactly like looking at a slice of modern bone. But of course I couldn't believe it. I said to the lab technician, the bones, after all, are 65 million years old. How could blood cells survive so long? So notice her first reaction was to question the evidence rather than her old Earth paradigm. Another paleontologist was quoted saying, and I quote, the state of preservation noted in the study is improbable, but obviously not impossible. So there you have it. The theory of evolution is not a scientific theory because any contrary scientific evidence is improbable, but obviously not impossible. Okay? They can explain anything. But even if scientists who believe in biblical creation, we can't prove the evolution theory of evolution is false. At least we can deny them the time they need to make it happen. Someone once said, time is a great healer, but a lousy beautician. You ever looked in the mirror and thought that? Okay. When I look in the mirror, I see that as well. That's a joke, by the way. You're supposed to laugh. Okay. Anyway, our experience with time is that things are not getting better. They're actually getting worse. In my case, the universe is expanding. That's happening too. So let me give you some of my favorite evidences for a young Earth. And there's heaps of them. Okay, we don't have time for all of them, but these are some I like. Okay, so the first is the recent date of civilization. So the beginning of civilization only dates back about 5,000 years to the beginning of written history. The earliest written history is supposed to be the Palette of Narmer from Egypt, dated about 3,200 BC. And archaeology has shown advanced modern cultures springing up suddenly, all at the same time as what we would expect right after the flood. So these cultures devised elaborate calendars, seagoing vessels, impressive buildings like the pyramids. We would have trouble building a pyramid, okay, even with modern technology. It's even hard to find a crane that could pick up those big rocks, okay, those big blocks that they used. Yeah, we've built some scale models some places, and that's even hard to do. So these ancient people obviously are really smart people, and they had technology that we still haven't quite figured out. My second one is, and if you have questions about any of these, just take notes and ask me at the end, okay? Second one is population statistics. So at a population growth rate of 2% per year, it would take about 1,100 years to reach a population of 6 billion, okay? Not that much more to get to 8 billion like we are today. If mankind was even 1 million years old, the rate would only be 0.002%. Okay, now you get a problem. You get a slow growth rate, you get a lot of inbreeding. So for example, the Florida panther was hunted down to just very few individuals. And the ones they could breed together, there's so much genetic similarity and so many mutations and so forth that these animals could survive. They'd essentially gone extinct. So what they had to do is take mountain lions from the west and breed them with the Florida panther to revive the population. So that's a problem. If you have a long period of time where there is very little reproduction, then you get a lot of inbreeding and the human race would go extinct, okay? And then there's the problem is, where are all the bones? You see, all the this is an old slide, so we're over 6 billion missing graves. We should say 8 billion these days. And that's a good question. You see all those, that little tree there. So you know the name of all these supposed human ancestors, like Australopithecus, this or that, or Lucy, or Turkana boy, and all these. But all those bones, if we had all those bones, put them all in one place, they'd fit into one coffin, and it'd have room to spare. So where are all the missing bones? Well, it's because they didn't exist. Okay, human race has not been around that long. And then we have the erosion of the continents. What would rocks that are millions of years old look like? And we can measure erosion rates. And, the point I'm trying to make is that million-year-old rocks wouldn't be on the surface of the Earth. Okay, they would have already eroded away. We were up in Pennsylvania, and I went to Penn's Cave. And that's one of these limestone caves that actually filled with water, and you take a boat through it. It's really quite nice. And so the guy there, the guide told me that the limestone that was there was 250 million years old, and the cave was, he said, was 50 million years old. And then he told us how the rate at which the stalactites formed and so forth. And I said, well, if it's really that old, all the stalactites would have filled the whole cave. how can we get through there if it's so old? So far, of course, he didn't have an answer to that. So modern erosion rates are so fast, according to geologists, that the continents themselves should have been reduced to sea level long ago. A recent study confirmed that outcrops, that is rocks visible from the ground, erode at an average rate of about 40 feet every 1 million years. These are secular numbers. So that means the time to completely erode most continents would be less than 50 million years old. So they're telling me that that cave was formed 250 million years old. That doesn't compute very well. It should have all been eroded down to sea levels. So secular geologists have to resort to rescuing devices, like periodic uplifts due to tectonic forces to explain the existence of today's continents. But the Appalachian Mountains, supposedly 250 million years old, they will tell you there was no uplift in that period of time, okay, by their actual words, okay? So, and considering that most of these areas are less than 1,000 feet above sea level, it's a wonder there's any dry land at all, okay, because of erosion. So here's a little graphic of the seafloor mud accumulating. You can see that mud entering the ocean's about 25 billion tons per year just from erosion. And the mud is accumulating on the bottom of the ocean about 400 meters. And some mud leaves because of subducting plates, because of tectonic forces and so forth, about 1 billion tons per year. Anyway, you add that all up, and you get a maximum age of about 12 million years. Now, I'm not saying that the Earth is 12 million years old. I'm saying it couldn't be older than 12 million years, which is far cry from the billions of years that they say. So here's the Mississippi River Delta. We know that 300 million cubic yards of mud are deposited in the Gulf of Mexico by the Mississippi River every year. If you divide the mud deposited by the total weight of the Mississippi Delta, you could determine that the age of the delta is about 4,000 years, okay? Works out to thousands of years rather than billions. Then you could look at the accumulation of different chemical compounds in the ocean. And for example, the oceans are not salty enough. As the salt's washed off the lands, the ocean gets saltier and saltier and saltier. This ocean's not nearly salty enough. It should be more like the Dead Sea than what we see today. So a lot of these indicators show that the Earth is thousands rather than millions or billions of years old. We were at Bryce Canyon. How many of you have been to Bryce Canyon? Okay, so you go to Bryce Canyon, it's an ice age thing. And you see all these hoodoos there, these spindly things because of erosion. And when we were there, they explained, the Park Service guy told us that they have a bench there for the visitors to sit on, but the erosion rate's so fast that every year they have to move it back so the visitors don't go over the side, okay? And I thought, at that erosion rate, the Bryce Canyon should be up in Canada somewhere, okay? And so, you just don't think about how long a million years is or how long a billion years is. I mean, just vast ages here, and you just can't imagine. I mean, they talk about the Grand Canyon, having like 70 million year old rocks on the surface and all, and they're all flat, okay? It doesn't ever rain there, okay? Why is it like this, just so, people take selfies, over the side they go, okay? And it's so knife edge and so forth. It doesn't look eroded, it looks young. Okay, we go on that vein for a while. Then we have the decay of the Earth's magnetic field. So in 1829, scientists made precise measurements of the intensity of the Earth's magnetic field. That's the force that moves the compass needle north, okay? It pulls the compass needle north. We can measure that force. And since that time, the strength of the magnetic field has decayed by about 7%. So that means the half-life, that is the time it takes for the field to drop by half of its strength, is about 1,400 years. Okay, so every 1,400 years, it's halving, okay? And we talked the other night about radiation from outer space, how the magnetic field protects us and keeps us from getting cancer and so forth. And but the problem is that magnetic field is getting less and less and less, okay? So if the sun sends a chunk of charged particles, solar wind, toward the Earth, we have less protection now than we had in the past. And maybe, just maybe, during the book of Revelation, where the kings of the earth hide themselves in caves, maybe that's not because the luminosity of the sun is greater, but there's 10 times more particles, charged particles from outer space, and the only place they can live is under the ground, in caves and so forth, because the magnetic field is so weak at that particular point. Right now, the magnetic field is decreasing at an alarming rate. There's what we call the South Atlantic anomaly, where there's an area of low magnetic field right off the coast of Brazil. When satellites go over it, they shut the satellites off so they won't get all their electronics fried when it goes over there. And the poles are moving. So the North Pole is headed towards Siberia, and it's going faster and faster and faster. The South Pole has left Antarctica. It's actually in the water between Antarctica and Australia. And the two poles, if they continue on their current path, will meet in Indonesia somewhere. Well, that's not going to happen. You can't have a North Pole and a South Pole in the same place. So some people think that we're getting ready for a polar flip, that the poles are going to flip over and south will become north and north will become south. And there'll be a time when our protective shield will completely go away and we'll be without that protection on the earth, perhaps during the tribulation period. Okay. And then we have comets. So comets are icy asteroids that orbit the sun. And you can go look online, go to the SOHO satellite, and you can actually look at the sun and see the comets go around the sun. Some comets go in, and you can see them come back the other side. Some of them just go in, and they go right into the sun, and they're gone forever. But comets lose about 1% of their mass every year on average. And for example, you remember Halley's Comet, okay? Back when Halley's Comet came around, they were all so excited because during the Middle Ages, when Halley's Comet came around, people could see it during the daytime when the sun was out. You ever seen a comet during the daytime with the sun out? Okay, and when it came around the next time in the 1970s or whatever, even with binoculars, it's just like a smudge on the sky. It's deteriorating. So every October, we go through the Orionid meteor shower, and that's pieces of Halley's Comet that have broken off. And so they're getting smaller and smaller and smaller, so there shouldn't be any comets left. The fact that there's still comets is evidence of the young age of the universe, of the solar system. Now, they say that there is a big comet reservoir out there, either the Kuiper Belt or the Oort cloud and so forth. The trouble is we've never seen them. So as we get our telescopes better, we still don't see that big reservoir of comets out there. And so it's just fictional at this point. The fact that there's comets is evidence for the young age of the solar system. And then you have the energy output of Jupiter. Remember we talked about this on Sunday, that Jupiter gives off twice as much energy as it takes in from the sun. Now, that's not a problem for thousands of years because it's still cooling down from the original creation. But for billions of years, what's the mechanism? What's producing all that energy? Okay? Probably little hamsters of wheels or something, I don't know. But they don't have any way of producing that energy. And so the fact that Jupiter, and it's not just Jupiter, it's Saturn and Neptune do the same thing, shows that those planets are young, thousands of years old, rather than millions or billions of years old. Otherwise, they would have cooled off by now. And then there is Pluto. Pluto is a traitor to the evolutionary cause. So they sent the New Horizons spacecraft to take a look at it because it's so far away, and scientists predicted it would have an old, heavily cratered surface. But what they actually saw were young areas where there were no craters at all, as you can see there. So they found that there was ammonia ice and water ice there. Now, ammonia is a fragile molecule. It can be broken down by ultraviolet light and cosmic rays in a fairly short period of time. So the fact that there's still ammonia on the surface of Pluto means that it's young rather than old. And So where does the energy come from that keeps Pluto young? Why does it have an atmosphere? Okay, why is it outgassing ammonia and methane and this type of thing? They have no answer. There's mountains on Pluto of ice, water ice, that are taller than Mount Everest. So how did they form? There's no tidal forces on. It's tidally locked to Charon, its twin, and so there's no tidal forces. So how do you form those big mountains on Pluto? One of the scientists, New Horizons scientists, said this was an example of a brand new geophysical law. So they're willing to change the scientific laws rather than accept the evidence that we see of Pluto being young. In fact, it's only 6,000 or 7,000 years old. So we started with boring biblical geologies, ended up with some exciting evidence of a young Earth, but all of it points to the trustworthiness of Scripture. So the Bible's not a science textbook, but everything the Bible says about science is true. Now, so let me just stop right here. I know Wes asked about carbon dating last night. We'll deal with that in just a minute. Is there any other questions on any things we just talked about? Any questions that came up in your mind from what you just saw? Yes?
Is that why they decided to make Pluto a dwarf planet?
So the definition of a planet is something that they vote on. So they get together, all the astrophysicists get together, and they say, is it a planet or isn't? They all raise their hands and so forth. So there's some indication they might vote it back in at some point. But the criteria of a planet is it has to be round, it has to be spherical, it has to have enough mass that it's round, and it has to be in control of its own gravitational field. And so the reason they demoted it is because Pluto is affected a great deal by Neptune. So Pluto weaves its way in and out of the orbit of Neptune so it's controlled by the gravitational force of Neptune. So it almost acts like a moon in a way, okay? So that's why they demoted it, okay? But then all the school children were upset. So we were, taught that there's 9 planets when I was in school. And so Pluto got demoted, so now there's 8 planets. And so they're looking for planet 9, or planet, some people call it planet X and so forth, and they're working hard to see if there's anything else out there, but I don't think there's any evidence for it. Any other questions? Yeah.
Isn't the dust on the moon evidence of a young Earth as well, being that they landed the Eagle and it only landed in a couple inches of dust?
So that's an old creationist idea that's been discarded. So creation science is just like any other science. We learn new things. So the reason why the dust on the moon is not an evidence of a young Earth is because of all the ionizing radiation coming from the sun. There's no atmosphere. So it acts like a welding torch. It welds those grains together and turns it into regolith. Okay? And so even as creationists, we would not expect a large amount of dust on the moon. So that's an argument we've discarded. Okay? Yeah. So penguins, is that what you said? You mean before the flood? Is that what you're saying? I don't know. I didn't live before the flood. Okay. We know some of the penguin fossils we've dug up from before the flood are really huge. I mean, they're like big, like 6 foot, so forth. So they were a lot larger, but we don't know how they lived back then. Okay. Oh yes, back there. So there's a lot of iron in the soil on the Earth and very little iron on the moon. So it's different in that regard, the difference in iron content. There's also differences in manganese content as well. So that there are some significant differences. Yes?
Driving through the mountains, like out east, you'll see areas that are cut through the rock, and you'll see the layers in the rock.
Mm-hmm.
You also see areas where those layers
Right.
something's heaved up. But what would you say is the origin of those layers? Did God just create those layers in the rock, or were they settling?
No, so all those layers are laid down during the flood. And so think of it this way. You have this rapid subduction down in the ocean bed, and it's all the original ocean crust has been subducted. So none of that original ocean floor it's all gone. It's all been, pulled into the earth. And so it pulled all that down. And, we often think of it raining and going up by the highest mountains, but you should also think about the fact that it's being pulled down underneath the water. It's being, and so then at the end of the flood, it all kind of pops back up again. So when it pops back up, it folds and breaks and gets different angles and that type of thing. Okay, so all that stuff is an evidence at the end of the flood. Yeah.
So every layer then that we see in the rock is from the flood.
Every layer you see in the rock, all the sedimentary layers are from the flood. Okay, and of course, so think about the flood this way. Think of it as you have. We've measured 6 or 7 tsunamis that were part of the flood. Okay, so it's not just coming up slowly. It's going up and then going back, going up, going back. It gets up higher each time, and finally, the last one, the Zuni mega sequence, actually covers the whole Earth. Okay, and before it goes back down again. And so when it does that, it's laying down sedimentary rock, but it's also eroding the ones that were already laid down before. So it's very complicated as far as the patterns that you see. But all that was laid down during the flood and then eroded by the later stages of the flood. So think about like the Grand Canyon. So what happened there is that the Rocky Mountains, they may not look light to you, but it's made of material that's actually lighter. That granite is lighter. And so it pops up because it's light, like a cork. And so the waters, because of the rotation of the Earth, the waters are generally going from west to east, okay, just like the air currents do today. So when it's covered with water, the water's going from west to east. Now the Rocky Mountains pop up, and they hit those Rocky Mountains, and there's no place to go. And so then they funnel back from the north and from the west and from the south back into a cut in the ground, and they widen that, and that's where the Grand Canyon formed, from all that water funneling back through the other way because the Rocky Mountains popped up. So a lot of interesting things like we can talk about that all day. Yes.
Earlier you said something about as things approach the speed of light, time begins to slow down.
Yes.
I don't know if you've read it or not. There's a book by Michael Gillen called Believing is Seeing. He's a physicist.
Okay. I haven't read it now.
Who had been an atheist and became a believer because of his study of physics.
Okay.
And he makes a big deal about God being light, and takes it to a point of almost literality of God being light, and the fact that God's eternality is a part of this light, this property that He is light. Do you?
It sounds like he takes things too far. It's just a metaphor. Okay. I think God is light is a metaphor. For what God is like. Okay. It deals with certain aspects, but I think he's taking it too literally. Okay. In my opinion. Okay. All right. Well, let's continue on. Let's look at the radiometric dating. A lot of people want to know how to deal with radiometric dating. So how do we deal with radiometric dating sequences? So we have like a parent isotope is carbon-14, a daughter is nitrogen-14. It's going from one to the other and has a half-life of 5,730 years. That's not a problem because that's a fairly short period of time. But you see with like uranium-lead, we're talking about billions of years, okay? So what's going on there? How do we deal with those radiometric dating techniques? So back in the 19th century, they didn't have radiometric dating techniques, but they already decided, because of how long they thought evolution took, that the Earth must be millions of years old. So Darwin started thinking that there was millions of years, in Earth's history, which was a radical break from those who believed in creation. We didn't get billions of years until the 20th century. It's still millions of years back then. But you see, they dated the rocks, the age of the rocks, by the fossils they contain, the index fossils, based on how they thought evolution worked. And they dated the age of the fossils by the rocks they found them in. So that's an ultimate circular reasoning, okay? So it's all dated by the theory of evolution, how fast they thought evolution took place. But finally, they got radiometric dating in the 20th century. Let me show you a little video that tells you about this. Oh, that's not a video. I thought that was a video. Oh, I guess it'll be coming later. I can't see the slides that are coming. There we go. So the uranium goes from it's a parent, and it decays down to the daughter. So the idea is you can figure out how old a rock is by how much of the parent is there, how much of the daughter is there, and you get an idea how old it is with some assumptions. So the first assumption is that we know what the conditions were when God created that rock. And how would you know that? How would you know what the original conditions were? Second, you would have to assume there's no contamination. None's been washed in or washed out. Thirdly, you'd have to assume a constant decay rate. And there's great evidence that the decay rates have not been constant over those periods of time. We've only been measuring decay rates since Madame Curie in the early 20th century. What do we know about decay rates 1,000 years ago or 2,000 years ago? We don't know anything about it. And we know that decay rates can change based on the neutrino flux from the sun. What do we know about the neutrino flux of the sun? Nothing. So we can measure it now, but we can't measure it back then. So there's all these unknowns. It's all based on assumptions that they're making. So how do we figure out how old radioactive decay rocks are? Well, you see like this uranium atom, it loses a helium nucleus. So you can count the radium atoms that have decayed in the rock. You can see their fission tracks, or you could actually measure the amount of helium that's still in the rock, and you get two different dates. So, for example, those uranium atoms are actually in a little gem called a zircon, and those zircons are embedded in granite. You see those little black flecks on the granite? That's called biotite mica. It has zircons in it, and that's where those uranium atoms are found. So we can look at it under a microscope and see what happened. So here's an actual picture of a radio halo. This is what we see if you look in the microscope. Sometimes you can take a diamond, an engagement ring, and look at it under a microscope, and you can see these rings, these damaged rings from the radioactivity. So we know the radioactivity took place. We just don't know how fast it took. But we know that every time a uranium atom decayed into lead, it produced 8 helium atoms. So you have two hourglasses. You have so the zircons, you could look at the radioactive decay rate. That is what people say it is today. You'll get millions of years. But then you can look at the helium leak data, and you get thousands of years. So which date is right? We know how fast helium escapes from rock. So the fact that we still see helium there would tell us that those rocks are young rather than old. So there must have been a time in the past where radioactive decay rates were much faster than they are today because the helium is still there. So how does radiocarbon work? Well, let's go back. I still think I had that. I had a video there. Did the video not work? Okay, let me try to go back. I thought we had a video, but I didn't see it. Okay, can you start on your end?
Every textbook in Science magazine teaches that the Earth is billions of years old, and the primary dating method used for determining this is what is called radioisotope dating, or radiometric dating. Now, this is a reliable method for measuring absolute ages of rocks and the age of the Earth, right? First off, many scientists now regard the age of the Earth to be between 4.55 and 4.6 billion years old. Okay, so if this method is reliable and accurate, why the 50 million year discrepancy? That seems like a lot. But let's get into some details here and see what's going on. Keep in mind that there's all kinds of scientific jargon on this topic, and so we'll just present a very straightforward, simplified version of the process. Radiometric dating is the process of estimating the ages of rocks based on the decay of radioactive elements in them. Basically, there are certain kinds of atoms in nature that are unstable and spontaneously decay into other kinds of atoms. For instance, uranium will radioactively decay through a series of steps until it becomes the stable element called lead. The original element is called the parent element, and the end result is called the daughter element. Radioisotope dating is commonly used to date igneous rocks, rocks which formed when hot molten material cooled and solidified. The dating clock started when the rock cooled. During the molten state, it is assumed that the intense heat forced any gaseous daughter elements to escape. It is assumed that once the rock cooled, no more atoms escaped, and any daughter element now found in the rock is a result of radioactive decay since that rock formed. The decay rate is measured in terms of half-life. That is the length of time it takes half of the remaining atoms of a radioactive parent element to decay. Now, of course, that can be measured in a laboratory, and it is assumed that since we know the decay rate, we can calculate backwards and come up with the age of the rock. But is that all there is to it? Here's where it gets tricky. It's true we can measure a decay rate using observational science, but there's another kind of science that is required to accurately calculate dates for rocks, and that is what we call historical science. Historical science deals with the things in the past, and therefore cannot be repeated and tested. Dating methods require both types of science, because in order to get accurate rock dates, one would have to accurately know both the decay rate and the initial conditions of the rock sample, right? Since radioisotope dating uses both types of science, we can't directly measure the ages of rocks. There are assumptions involved. For instance, how do we know what the initial conditions were in the rock sample? How do we know the amounts of parent or daughter elements now in that sample haven't been altered by other processes in the past? How does someone know the decay rate has remained constant since the rock formed? The answer is they don't. Let's simplify here and talk about a typical hourglass. Let's say you walk into a room and you see an hourglass with sand at the top and sand at the bottom, and some sand sprinkling from the top chamber to the bottom. Well, observational science would allow us to see and measure the sand, and then calculate how long the hourglass has been running, right? We could make our sand measurements and then calculate when the hourglass was turned over, right? Well, those calculations could be wrong, because we may have failed to consider some major assumptions, like, was there any sand at the bottom when the hourglass was turned over? Has any sand been added or taken out of the hourglass? Has the sand always been falling at a constant rate? Since we did not observe the initial conditions when the hourglass started, and we haven't been watching the sand all the time since then, we must make assumptions. All three of those assumptions can affect our time calculations. Now, of course, there's more to understanding all of this, but enough said.
You got that? Okay. That was designed for teenagers. Teenagers see things a lot faster than older people do. Okay, well, one more thing, and then you can ask me questions about it. That is, we'll look at radiocarbon dating. Remember, we said that radiocarbon dating is a lot faster. So what happens is cosmic rays hit nitrogen-14 molecules, and they turn them into carbon-14, which is unstable. The carbon interacts with, forms radioactively labeled carbon dioxide, and the trees take that in, and the animals eat the plants, and they take it in. And so one of the great scientific principles is that dead organisms don't eat. Okay, you stop eating as soon as you die. Okay, want me to prove that to you? All right. So when you die, then the radiocarbon actually turns back into nitrogen. Okay, so we can measure. So right now, all of us are living, and we all have the same carbon-14 ratio in our bodies because we all ate today. All right, and when we die, then it starts decaying. So you theoretically can use that to figure out when somebody died, and we can look at old bones and mummies, anything made of carbon, and figure out how old it is based on that. Now, I think I mentioned to you this before, but notice that these are analysis of coal samples. And what we find is the coal samples all have about the same amount of radiocarbon in them as modern carbon. And so that tells us that the coal was formed thousands rather than millions or billions of years ago. And it all formed at the same time. So when the flood came, it wiped all the vegetation and buried it and formed the coal. And so we know that all that coal was formed at the same time, thousands of years ago, rather than millions and billions of years old. In fact, everything, all forms of carbon, deep well carbon dioxide, even diamonds have this new carbon in there. So the fact that we find carbon-14 in everything tells us, because the carbon-14, after 100,000 years, there wouldn't be any left, okay? So it can't possibly be millions or billions of years old because it would all be gone. We couldn't measure it. So when I would teach about accelerated mass spectrometry to my students in analytical chemistry, I'd show them, I'd show them the new carbon and everything. And they'd say, well, how do the evolutionists deal with that? There's obviously new carbon there, carbon-14. And I said, well, they know it's not there. If it's there, it must be contamination. So they take the dial and they zero it out, like that. My students went, like that? Really? They just zero it out? Yeah, they just turn the dial and they zero it out because it's not there. It can't be there because it's too old. And you say, well, why don't they use a standard sample that doesn't have any carbon-14 in it? And the answer is because they don't exist. There's no source of carbon on Earth that doesn't have modern carbon in it. And so that means there's nothing on Earth that's older than 100,000 years, okay, based on the chemistry. And so they reject that. They believe the Earth is millions and millions of years old, so it has to be there, so they just zeroed out, and that's it. That's the end of the show. Okay, anybody have any questions? I know that's very technical, but the question was asked. What questions do you have about that? Yes? Okay, so how do we know the difference between a parent element and a daughter element? So in the case of uranium, uranium is the heavier, more complex element, and so it's going to a lighter, less complex element, lead, and the lead's stable. So once it gets to lead, it stays lead forever. It never goes to anything else. So you have this whole series that you go through down to lead. So that's how you tell. What you're left with is the daughter. Okay? Anything else about that? Okay, so we have an opportunity. Any other questions before we end tonight? So remember, we'll light your hand on fire if you're interested in that. You've been a wonderful audience. I really enjoyed talking to you. Sorry it had to be so technical tonight, but everybody wants to know about radiocarbon dating. That film I showed is actually on YouTube. You can look it up, and if you want to show it to your friends or neighbors or whatever. And so it's put out by Answers in Genesis. And I think it describes the whole process pretty as simply as you can, okay? All right, Pastor?